Welcome to the notes for H4-2. Today we're going to start out by looking at solving equations both algebraically and graphically. And when we solve them graphically, we're going to focus on a method that treats them as a system of equations. So we'll explain that part when we get to it. Let's look at problem number 1. We've got solve the following equation. You see the square root of x plus 2 is equal to x. If we're going to solve that one algebraically, I'm going to first just copy it down. And we're going to just go ahead and look at it. We've got a square root of x plus 2 is equal to x. So since my square root is already isolated by itself, we're going to go ahead and square it to get rid of the square root. But we have to do it to both sides. When we do that, we should have x plus 2 now equals x squared. So we're looking at a quadratic equation at the moment, so we'll go ahead and set it equal to 0. And 0 is equal to x squared minus x minus 2. You can solve this however you want. It's a pretty easy one to factor, so we'll go ahead and do that on my end. I've got x plus and x minus, so we've got, let's see, a minus 2 and a positive 1. We'll use our zero product property to finish solving. So we get x is equal to negative 1 and x is equal to 2. Now, it's really important that we make sure we're checking our answers, especially when we're solving radical equations and we get 2 answers. Let's check them here. We're going to check 2 first. So if I'm going to check that my x equals 2. So if I plug in 2 there, I'm going to have 2 plus 2 inside the square root, and that should equal 2. Right, and that gives us the square root of 4 is equal to 2, which is a true statement. So we can conclude that x equals 2 as an answer. And then let's try our negative 1. Right, so we're going to check that x equals negative 1. So the square root of negative 1 plus 2 is equal to negative 1. Which gives us the square root of 1 equals negative 1, but the square root of 1 is 1, so that is not going to work, which means that x equals negative 1 is an extraneous solution. It does not work with this equation. So our answer for this one should be x equals 2. Now, let's look at a second method for solving the same equation. We're going to solve it graphically by turning it into a system of equations. So we have here the square root of x plus 2 is equal to x. So make sure I copy it down correctly. And to turn it into a system, we're going to focus on 2 parts, the left side and the right side. We are going to create a function from each side. So I'm going to write y is equal to the left side, which is the square root of x plus 2. And then my second function is going to be y equals the right side, which is y equals x. So we're turning this into a system of equations, and we're going to graph each of these. So when I graph the square root of x plus 2, right, I know my locator point is at negative 2, 0. And I'm going to just follow my pattern for graphing a square root function. I'm going to go right 1 up the square root of 1. Back to my locator point, then over 4 to positive 2, and then up 2. Back to my locator point, I'm going to count over 9 to 7, and then go up the square root of 9, which would be 3. So this is what y equals the square root of x plus 2 looks like. Right, this is the one that's y equals the square root of x plus 2. And now we'll graph our second one where it's y equals x. Right, so our y-intercept would be 0 and our slope is 1, so it should just kind of go up to the right like this. And down to the left. I don't need to go all the way down because there's nothing happening down there, so we'll just go right up like this. Now, one thing you'll notice here is we have one intersection point, and that intersection point is the point 2, 2. Now, that means that our input was 2 and our output was 2. When we go back to our original problem here, right, this is our original problem at the top, it is an equation, and we're looking for what input value makes it true. So in this case, our solution is actually the x-coordinate, even though they're the same thing. And this will become a little clearer when we do a couple other problems here, but one thing we should probably write down here is the solution to the equation can be found at, I'd say as the x-coordinate of the intersection point. This is really important to remember. Okay, so it's the x-coordinate. It's not the whole point, right? Because our original problem, we need a value, right? We're not going to get an answer that's a point for an equation like that. We need a value. That value here is x equals 2. Okay, where do we find it? We find it at the intersection point. It's the x-coordinate of the intersection point. All right, let's move on to another one. Second one says solve for x. We have x plus 1 squared minus 2 equals 7. Okay, and you can solve this any which way you want, and there's multiple ways for solving this equation. I'm going to just undo it backwards. Right, so I'm going to add my 2 to each side. So I now have a quantity of x plus 1 squared is equal to 9. To undo the square, we'll take the square root of each side. Now remember, the square root of something squared will give us the absolute value of what's inside. All right, so we have the absolute value of x plus 1 should equal 3. So x plus 1 should equal positive or negative 3. And then we'll just set each of those equations and find our answers. So we subtract 1 from each side, we're going to get x equals 2. We subtract 1, we're going to get x equals negative 4. So it looks like there's 2 answers here. We could always do our check now, right? If I wanted to check it, I'll check the x equals 2 first. I've got 2 plus 1 squared minus 2 is equal to 7. That's 3 squared, which is 9, minus 2 is equal to 7. So 7 equals 7. We know that that answer works. So x equals 2 works. And now we'll just go ahead and try our x equals negative 4. So we have negative 4 plus 1 squared minus 2 is equal to 7. That'd be negative 3 squared minus 2. So 9 minus 2 equals 7. Hey, 7 equals 7. That means that that one also works, right? So our second answer, x equals negative 4, works too. Now, when we go to solve this one graphically, right, we're going to take our x plus 1 squared minus 2 equals 7. And we're going to do it just like we did in the previous problem. We're going to take our left side and make a function. And we're going to take our right side and make a function. So the function on the left would be y equals x plus 1 squared minus 2. And the one on the right would be just y equals 7. Let's graph each of those. So the first one we know is going to be a parabola with a locator point at negative 1, negative 2. We've got standard growth, so over 1 up 1, over 2 up 4, over 3 up 9. Here's our nice parabola. I try to be as accurate as you can because, right, you're looking for where they're intersecting. So if you do a bad job graphing it, your intersection might be a little off. Our second one, y equals 7. Remember, this is just a horizontal line. So our y equals 7. So that's just going to run straight across here. You can see we hit it 2 real nice clean points. Okay. There's a point here and a point here where they intersect. So one of them looks like it's the point -4, 7, and the other one is the point 2, 7. And again, remember, we're looking for a value here because we're solving this equation. We're just looking for x, so this is going to be a value. So it looks like our solutions are just going to be just the x coordinates. So let's say here that x equals -4 and x equals +2. And if we kind of scroll back to the previous problem there, you can see that it was the same answers that we got up here. So we've got +2 and the -4. All right, let's move on to the next one here. We've got example 3. We've got solve for x. The absolute value of x minus 4 minus 1 is equal to 1/2 x. So this is what I worry about a little bit here. Sometimes students struggle with these absolute value equations. So I'm going to set it up first. I've got x minus 4, and then we have minus 1 is equal to 1/2 x. Now our goal here will be to isolate the absolute value when we have absolute value brackets in an equation. So the first thing we would do, right, is we would add the 1 to each side. Let's just get rid of that. When we do, we've got the absolute value of x minus 4 is going to equal 1/2 x plus 1. Okay, and then when we think about it, I'm going to kind of do a little side note over here. Right, when we do something like the absolute value of x minus 4, let's just set it equal to, like, say 5. Right, so remember, when we're doing the absolute value of something is equal to a number, the number that we end up with inside of here, right, has to make the statement true. So in this case here, when we're looking at this one, right, if I put a 5 in here, right, that would work. So if I put 5 in there, that would work. If I put -5 in here, the absolute value of -5 is also 5, right, because it's 5 units from 0. So there's two numbers we need to have, either positive or -5 need to end up inside of here, which means that x minus 4, if we take it out of the absolute values, it has to end up equaling either positive or -5. And basically what we would do then, right, is we would try to say, well, what value of x when I take away 4 is going to give me 5, and what value of x when I take away 4 is going to give me -5, and then we would finish solving. Okay, so we're going to do the same thing over here on this side. Right, since we have our absolute value by itself, right, we know that what we have inside of here, when we take it out, has to end up equaling the positive or negative version of whatever's on the other side. In this case, it's not a number, it's an expression. But then we'll take that and we'll break it into 2. We'll say x minus 4 has to equal the positive version, which would just be 1/2 x plus 1. I don't need any parentheses there. And then for my -1, right, we're just going to take that negative and distribute it through when we rewrite it. We're going to say x minus 4 would have to equal -1/2 x minus 1. And now we've got two equations that we can solve to find x. Okay, but notice at no point in time did this x minus 4 ever change. It's the exact same thing all the way until we get it to be two equations with no absolute values. Now, however you want to solve it, for me personally, I would just go ahead and multiply both sides by 2 because I don't want to deal with the fractions. So I'd have 2x minus 8 is equal to x plus 2. And then I would just finish solving. Subtract x, add 8, and we're looking at x is equal to 10. And then same thing on the other side. We're going to take it and we're going to multiply both sides by 2. So I'm going to have 2x minus 8 is equal to -x minus 2. We're going to add our x, add 8, and we're looking at 3x is equal to 6. So when we divide, we're going to get x is equal to 2. Now for time's sake, I'm going to tell you, if we plug both of these numbers back in, they do both make the statement true above. Okay, just because I'm short on time, I want to make sure I get through everything here. I'm going to go ahead here and look at the graphing part of this. So we're going to graph the absolute value of x minus 4 minus 1 equals 1/2 x. Right, just as we've done the previous problems, we're going to break it into two functions. Hopefully you're getting good at this part now and you're getting comfortable with what you need to do. Absolute value of x minus 4 minus 1, and this one would be 1/2 x. So for the first one, our locator point would be at 4, -1, and it's absolute value, so we know that since there's no stretch factor, it's just making that nice V shape, going over 1 and up 1. All right, try to graph them as accurately as you can. That one's a little off there, but I'll go with it for now. All right, and I graph my 1/2 x. My y-intercept is 0. And I'm going to rise 1 and run 2. Rise 1 and run 2. And we say we hit it there in a couple spots. So now I'm going to just connect that line. And you'll see we get an intersection point right here and an intersection point right there. This point is the point 2, 1, and this point is the point 10, 5. Okay, but remember, we're looking for a value, not a point. So our answer here would be the x coordinates, x equals 2 and x equals 10. Same things we got on the previous slide when we were solving it algebraically. Now, why is this method of solving by graphing important? Because we can't always solve it algebraically. Looking at this example 4, we have solve for x. We have 3x plus 10 equals 1/2 to the power of x. We don't know how to solve this algebraically at this point in our math careers, so what we're going to do then is go ahead and solve it by graphing it as a system. So I'm going to do just like I did in the previous problem. I've got y is equal to 3x plus 10, and I have y equals 1/2 to the power of x. Now y equals 3x plus 10, right? Our y-intercept is 10. We can't go up anymore, so we'll go down 3 and back 1 just to graph that line. Connect those points to make our nice line. Got a little shifty on it there, sorry. There we go. Okay. And if you don't remember how to graph 1/2 to the power of x, right, you could always just take it and make a table. Throw in some input values to get some output values. So when I plug in here, right, if I plug in 1/2 to the first power, right, that's going to give me 1/2. If I plug in 1/2 to the second power, that gets me 1/4. If I do 1/2 to the power of 0, that gets me 1. 1/2 to the negative first would give me 2. And then 1/2 to the negative second there would give me 4. Let's plot those on here first. So I have a point at, when I'm looking at this, right, -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. So I'm going to say here, -2, 1, 2, 3, 4. Oh, look, there's an intersection already. We have -1, 2, 0, 1, 1, 1/2, 2, 1/4, and if you remember, right, this is an exponential function, and it will have this horizontal asymptote on the x-axis, because this is like one of our parent graphs. And if we continue to go backwards here, we'd see at -3, we'd have an output of 8, so our function would look like this. So, as we look at it, right, there's an intersection point. Our point looks like it's at the point -2, 4. So since we're talking about an irregular equation, right, that value that we're looking for is just the x coordinate. So we're going to say here that negative 2 is our solution. And we can check this one too, right? Let's plug it in. 3 times negative 2 plus 10 is going to equal 1/2 to the power of negative 2. We already said that 1/2 to the power of negative 2 is 4. And when you see on the other side here, this would be what? Negative 6. And negative 6 plus 10 is 4. So it checks out. We know that it's correct. So our answer for this equation is x equals negative 2. If you have additional questions or concerns, or you just want to discuss it more, please reach out to me.